All right, we're going to work through our quadratics review guide, and we're going to start with graphing. We should be able to graph quadratics in standard, vertex, and factored form, and know that the x-intercepts are the solutions. So we're going to start with this parabola on the right and write it in each of our three forms, starting with vertex form. Vertex form, y equals a x minus h squared plus k, where h and k are the vertex. Looking at the parabola, we can see that a is going to be -1 because it opens down. We can also see that the vertex is 1, 9, the highest point on the graph. When we plug those values in, we get y equals -1, x minus 1, remember x is always the opposite of what it appears to be on the graph, plus 9. And we're done with vertex form. When we write our equation in intercept form, we're going to use our two intercepts and our known a value of -1 to write the equation. We can see that our p-value is -2 and our q-value is 4. Does not matter which is which. When we plug those in, we're going to be doing the opposite. Again, x is a liar. So x minus -2 gives us a factor of x plus 2, and x minus +4 gives us the factor of x minus 4. And we are done with intercept form. In standard form, that's when our parabola is all multiplied out and we are unable to look at a graph and determine the b and c values. So instead, what we will do is we'll take our intercept form and we will FOIL that. So we're going to start by multiplying our two binomials together. We could also use the box method. I'll do both. If we FOIL, we're going to multiply x times x for x squared, our outer terms for -4x, our inner terms plus 2x, and our last terms for -8. We still have the -1 in front. That gives us x squared minus 2x minus 8, and then we distribute our -1, -x squared plus 2x plus 8 is our equation in standard form. If instead you choose to box those two binomials, we'll get the same four terms. Put your binomials around the outside of the box and multiply in x squared plus 2x minus 4x minus 8. And you can see that's exactly the same thing we got when we used the FOIL method instead. So use the method that works for you. We've gone from a graph to our three equations. Now we're going to go from our three equations to the graph. Our first form in problem number 2 is vertex form. And just as a reminder, sorry, I made an error there. Vertex form is y equals a x minus h squared plus k, where h and k are the vertex. X is always the opposite because your x is a liar. So our vertex would be read as +3, +2. And again, we can tell that just by looking in the equation. We also know that this opens down, so I'll make a note of that because we have a negative in front. And the axis of symmetry always goes through the x-coordinate of the vertex, x equals 3. When we make our table of values, always put the vertex in the middle, so 3 and 2. I'm going to choose two values less than 3 and two values higher than 3, and we'll use symmetry to find our points. When we use 2 as our x value, we're going to plug that straight into the equation 2 minus 3 squared plus 2. And just remember PEMDAS, we're going to square the -1 first, which gives us -1 plus 2, or 1. So our point is 2, 1. Now we're going to plug in our 1 value. And again, PEMDAS, we're going to square the -2 first. That gives us -4 plus 2, or -2. Using symmetry then, we know that this side should be 1 and this side should be -2 with the 5. So when we go to graph, I'm going to plot the vertex first. I know that this opens down from our point 3, 2, so to the right 3, up 2. We also know that our axis of symmetry is right through that vertex at x equals 3, so we can sketch that in. And now we're going to plot our other points. I'm going to plot the 2 that I calculated, over 2, up 1, and over 1, down 2. Then using the idea of symmetry, these exist on the other side of the axis of symmetry, which should be our points 4, 1. So over 4, up 1, that checks out. And over 5, down 2, that also checks out. Now we can connect our points and see our parabola that opens down. The domain is all real numbers, or -infinity to +infinity. You can write either one. Our range goes from -infinity to the y value of our vertex, which is 2, and that is included because it's a point on the graph. We can also write that as y less than or equal to 2. Either version is 100% correct. We'll move on to problem number 3, which is intercept form. And just as a reminder, intercept form looks like that. We know our graph opens up. We have a positive a value. When it comes to finding the vertex, we're going to start with the x-coordinate, and we have a formula for that. We're going to add the intercepts and divide by 2. So our first intercept is -4 because x is a liar. Our second intercept is +1. I apologize. Our version should say 2. So this is +2. -4 plus 2 gives us -2 over 2, which is -1. So that is the x-coordinate of the vertex. Just as we did with the points before, to find our y value, we're going to plug in -1. We plug it into both spots where -1 is. We're going to execute PEMDAS. We're going to simplify inside the parentheses first, which gives us 3 times -3, which is -9. So we know our vertex. That means our axis of symmetry is x equals -1. And you'll notice we only need 2 other points to graph, and we already know those points because we're in intercept form. One of our intercepts is -4. And of course, if it's touching the x-axis, the y value is always 0. Our other x-intercept is 2, and that pairs with 0. Now we have 3 points, which should be enough to draw our graph. So I'm going to go to the left one and down 9. And then we're going to plot our intercepts at -4, 0, there to the left of the y-axis, and at 2, 0, there to the right. I'm going to sketch in the axis of symmetry. Goes right through the vertex. And then we'll connect our points for our parabola. Since we have arrows extending to the left and to the right, the domain will be all real numbers, or negative to positive infinity again. You can write it either way. Our range, we start at a value of -9 and we go up from there. So in interval notation, we're going to start at -9 and we're going to include that with the closed bracket. And we're going to go up to positive infinity, or if you prefer set notation, you can say that y is greater than or equal to -9. Either one is 100% correct. Oh, excuse me. The last problem we're going to do with graphing is in standard form, which is ax squared plus bx plus c. And we also know that this opens up. Our a value is positive. If we're going to find our vertex, we're going to start with a formula to find the x-coordinate of the vertex, which would also be the axis of symmetry. x equals the opposite of b over 2a. So you'd want to put that on your note card. b is -2. So when we plug that in, we get +2 over 2 times our a value of 1. That gives us 2 over 2, which tells us the x-coordinate of our vertex is 1. So I'm going to go ahead and put that in our answer blank for the vertex and also put it in the middle of the table, because to find the y-coordinate of the vertex, we're going to plug that x value in. So we're going to plug that in and square it, and then just do some PEMDAS. 1 minus 2 would be -1 plus 3 would give us 2. So our vertex is at 1, 2, opening up from there, and our axis of symmetry would be at x equals 1, straight through the vertex. The other points that we want to use would be to the left of 1, so 0 and -1 are good choices. And then we'll go to the right and go to 2 and 3. And again, we're going to find 2 of these and then find the other 2 with symmetry. We'll start by plugging in 0 through our equation. Sorry, that's a -2 times 0 plus 3. 0 minus 0 plus 3 gives us 3. And then we'll plug in -1. Make sure to use parentheses, especially when you're plugging in a negative. -1 squared is 1. -2 minus 1 is +2, and we'll add 3 to give us 6. And with the idea of symmetry, then we know our last 2 y-coordinates for the rest of our table are also 3 and 6. We can check that on the graph to make sure everything lines up. Our vertex is over 1, up 2, and the axis of symmetry, again, would go straight through that vertex. Then we're going to plot our other points, 0, 3, and -1, 6. And if our calculations with symmetry are correct, we should go over 2 and up 3. That works out. We should go over 3 and up 6. That works out. We can see our symmetrical points are correct. We can connect the dots and see our parabola that opens up. Our domain, arrows to the left and right, -infinity to +infinity, or x is all real numbers. And for our range, we're starting at the lowest y value of 2. That's our vertex, which would also be the minimum. It's included, and we go up to +infinity. We can also say y values are greater than or equal to 2 if you prefer set notation.